Welcome to all on Sethi. In today's session, I'm going to discuss very basics of charge properties and Coulomb's law. Under the chapter Electric Charges and Fields +2 physics. Right? Now, let's start the question. Question is, a polythene piece rubbed with wool is found to have a negative charge of 3 × 10⁻⁷ Coulomb. Estimate the number of electrons transferred from which to which. Second, is there a transfer of mass from wool to polythene? Right? This question is very simple to clear the properties of the charge. Right? This is applicable for all 12th standard, JEE, main, NEET, and CUET, etc. etc. Basic properties, concept, application, solution. Basic properties: charge is scalar quantity. Charge can be added or subtracted vectorially or algebraically. Can be added algebraically. Algebraically, simple plus minus, right? Charge is always charge exists without mass. Charge cannot exist without mass. Cannot exist without mass. Though mass mass can exist without mass. Third, additive nature of electric charge. Additive of charge is a property due to which total charge system is obtained by algebraic sum of all the charges present anywhere on the system. Right? Next, if the size of charge bodies are very small as compared to the distance between them, they can be considered as a continuous distribution charge or point charge. That can be considered as a point charge. Conservation of energy. Conservation of electric charge. Charge can neither be created nor be destroyed. In physical process, charge may be transferred from one part of the another part of the system, but the net charge always remains same. Next, quantization of charge. So, the charge on any body can be expressed as an integral multiple of basic unit of charge. That is charge on one electron. This phenomenon is called quantization of charge. Next, Q equal to N into E. E is the electronic charge. That's value is 1.6 × 10⁻⁹ Coulomb. Coulomb is the SI unit of charge. N is the integral multiple 1, 2, 3, 4, anything. Right? Now, next, let's start the cause of quantization. What is the cause of quantization? Quantization charge occurs because one body is rubbed with another body. Only integral multiple of electrons, integral number of electron is transferred. That is the cause of quantization. Now let's start the question. Question is Q equal to NE. This is according to now according to the question given is how much charge is given? 3 × 10⁻⁷. Q equal to 3 × 10⁻⁷ Coulomb. Q equal to E we know 1.6 × 10⁻⁹ Coulomb. Right? We have to find the number of transfer electrons. Right? On substituting 3 × 10⁻⁷ equal to N into 1.6 × 10⁻⁹. On simplification, N comes out to 1.875 into 10⁻⁹. Right? Number of electrons transferred. Of course, what is the question? Polythene piece rubbed with a wool is found to have a negative charge. For polythene piece rubbed with wool is found to have a negative charge. Charge on polythene is negative. Charge on polythene is negative. Means from wool to polythene. Electrons will be transferred. Electrons will be transferred from wool to polythene. Second part is there any transfer of mass from wool to polythene? Now in this, I have discussed the property charge cannot exist without mass. Yes, there will be also mass transfer, but very negligible, because mass of electron is 9.1 10 to minus 31 kg, right? Now next, Coulomb's law. I will discuss the Coulomb's law. Now topic will be Coulomb's law. Question is, for point charges QA 2 microcoulomb, QB minus 5 microcoulomb, QC QD minus 5 are located at the corner of the square ABCD of side 10 centimeter. What is the force on charge of 1 microcoulomb placed at the center of the square? Right? Now, let's start the concepts applicable first. What is Coulomb's law? According to Coulomb's law, the force of interaction that may be attractive or that may be repulsive depending on the charge. If the charges are like charges, repulsion will be there. If the charges are unlike charges, there will be attraction. Like means both are same nature. Unlike means both are of opposite nature. That will be proportional to product of the charges. Product of charges. And it will be proportional to the distance between them. Distance between them. Mathematically, F equal to 1 over 4 pi epsilon naught product Q1 Q2 upon R square. Say this is charge Q1, this is charge Q2, distance between them is R, right? Value 1 over 4 pi epsilon naught is 9 to 10 to the power 9 SI unit, right? Epsilon naught is 8.85 10 to the power minus 12. And it's called permittivity of the free space. Its dimensions are m to the power minus 1, l to the power minus 3, t to the power 4, a square, right? Coulomb's force acts along the straight line connecting the points of location of charges. It is central and spherically symmetric. What is definition of 1 Coulomb? 1 Coulomb में क्या करना होगा? 1 Coulomb is a charge which when placed at a distance of 1 meter from another charge of same magnitude in vacuum experience an electric force of repulsion of magnitude 9 10 to the power 9. Right? 1 Coulomb of charge is defined as like this. Regarding Coulomb's law, Coulomb's law of attraction, Coulomb's law of attraction is two-body interaction. Hence, it is not affected by presence of the other charges or absence of the other charges. I think both. Presence or absence of other charges. Coulomb's law is holds not only stationary charges or moving charges. Only for holds good only for, in this case, only point charges. Point charges, right? Regarding absolute permittivity. Relative permittive medium is defined as the ratio of dielectric force between the two, you know, F air 1 over 4 pi epsilon naught Q1 Q2 upon R square. This is equation 1. And F medium 1 over 4 pi epsilon naught into K Q1 Q2 upon R square. This is equation 2. In that case, if we divide these two, we get K. That is the relative permittivity of them. This is the ratio of two forces. Relative permittivity of medium is defined as the ratio of electric force between the two charges separated by a certain distance in vacuum to the electricity force between the same two charges separated by the same distance in that medium. Right? That is known as relative permittivity. Next, Coulomb's law in vector form. Coulomb's law agree with the Newton's third law. Newton's third law. Newton's third law. Comparison of Coulomb's law with gravitational force. Both Coulomb's and Newton's force follow inverse square law. That is inversely proportional to 1 over. You know Newton's law of gravitational force is F equal to capital G universal gravity M1 M2 upon R squared. Attractive always. Newton's law of gravitational force is always attractive. And whereas Coulomb's force may be attractive or repulsive depending on the nature of the charges, whether they are like or whether they are unlike. Electric force is much stronger than the gravitational force. Fe, I think, check Fg, right? 39. If charge Q is divided into two parts, Q1 and Q2, means Q equal to Q1 plus Q2, the repulsive force will be maximum when both are equal, when Q1 equal to Q2, right? Next. Next, I will start the question. The square is there. A, B, C, D. If you join them, you join them. This is right. The square of side 10 centimeter. This is at point P. Charges are minus 2 and 5. 2 and minus 5. 2 microcoulomb minus 5 microcoulomb. 2 microcoulomb minus 5 microcoulomb. At point P, it is 1 microcoulomb. Now, we have to find four charges. FPA, FPB, FPC, FPD. Again, everything 1 over 4 pi epsilon naught. Product of the charges. 5 FPA. That is 2 into 1. 2 into 1 into 10 to the power minus 6 into 10 to the power minus 6 divided by R square. That is PA square. Right? What will its nature? Its nature will be PA. Both are of same nature. Force will be repulsive. It will be, force on this will be along AP produce. Along AP produce. Along AP produce. It will be in this direction. FPB, FPC निकाल लीजिए पहले 1 over 4 pi epsilon naught 2 into 10 to the power minus 6 into 10 to the power minus 6 upon P C square. In this case, this will be opposite nature. So it is the same nature, repulsive along CP produce. Along CP produce. Means these two forces are equal in magnitude but opposite in nature. As PA equal to PB equal to PC equal to PD equal to, by geometry, by geometry. Okay. In that case, both are acting in the opposite direction. Therefore, FPA and FPC are equal in magnitude and opposite in direction. Opposite in direction. Therefore, will cancel out. Cancel out. And similarly, FPB will be equal to FPD. It will be PB. This will be attractive in nature. It will be attractive in nature means this will go PB produce along PB. FPB will be along PB, along PB, PB, and FPD will be along PD, attractive in nature, PD, along PD. Both are along PD. Both are opposite in nature, equal in magnitude, right? Therefore, also cancel out. Also cancel out. Therefore, net force at point P will be equal to 0. If the 0 cancel out, then simple net force on this, apply the law of parallelogram forces, then resultant will be the final answer. Right now, I will start the question on algebraic sum of charges. Now, the question is on distribution of charge on identical bodies. This question has been taken from JEE Main 2003, applicable for NEET, JEE Main, etc. etc. Two identical conducting spheres. One is P, one is S. Charge on this is Q, charge on this is Q. Repel each other with a force is 16 Newton, repulsive force. Right? Separated by distance, say R. Say. Right? Now, a third charge S. Third charge S. Identical in shape. S. So what will happen? इस पे जीरो चार्ज है इनिशियली, इस पे क्यू चार्ज है, इक्वली डिस्ट्रीब्यूट हो जाएगा. चार्ज ऑन पी विल बिकम क्यू बाई 2 and charge on this is S, this is P, this is R, this is R, this is R. Right? In that case, R is come into contact with this. This is Q by 2, this is Q. Q plus Q by 2, that is 3Q by 2, will be shared equally as identical. इस पे underline करो as identical. The sphere is there. Therefore, 3Q by 4. So charge on S will become, this is P Q by 2, this is S 3Q by 4. We have to find the force separated by the same distance R. Now, from the given information, initially F will be equal to 1 over 4 pi epsilon naught Q into Q upon R square. That is equal to 10 Newton. This is equation 1. 1 over 4 pi epsilon naught. Right? In second case, F dash will be equal to 1 over 4 pi epsilon naught Q by 2 into 3Q by 4 upon r square, that is comes out to be 1/4 pi epsilon naught 3 q square by r square into 3 by 8 from equation 1. From equation 1, we get 16 into 3 by 8, that is to 6 Newton. Yani ki force of repulsion will be there and that will be 6 Newton. That is the D option. Now I will repeat it again. Option D is correct. D option is correct. In this case, shedding of charges was there. Initially, charge Q, another identical. अगर identical नहीं हो तो another ratio में double. In this case, identical, in which case it will be equally shared. Now, this is P and this is R. So, P, Q plus 0, Q equally shared divided by 2. Q by 2 is पे आएगा, Q by 2 is पे आएगा. Now, this is, bring it here. This is Q, this is Q by 2. Q plus Q by 2, 3Q by 2. Equally shared, half कर दिया. Half करने के बाद, फिर इसके बीच force. Keeping the distance same, we have to find the new force acting between them. Simplify, we get the answer 6 Newton. D option is the correct. Right? Now I would like to request. If you are new to my YouTube channel, Sethi and like this video, please subscribe and share the channel, press bell icon to receive updates on upcoming concept clearing videos. Thank you. धन्यवाद. बहुत बहुत धन्यवाद जी. बहुत